Hey guys, welcome to my channel. Today we are going to talk about duck typing in Python. There's a saying that goes like this: if it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck. Dynamic typed languages like Python and JavaScript have an interesting characteristic of letting an object respond to a call according to the definitions of methods and attributes it has, independently of its type. This means that the type of the object, its own class, or the class it inherits from doesn't matter. The interpreter only cares about the interfaces the object has. So let's see this in action with a code example. I already have a terminal ready here with a Python script file created. So let's start. First of all, I'm gonna create this class duck with a single function definition. I can swim self. I'm gonna just print a simple phrase, quack and swim. I'm gonna create another class very similar to this one. I'm gonna call it bird, and I'm gonna keep the same function, quack and swim, for this class bird. Then finally, I'm gonna create one more class. I'm gonna call it frog, and I'm gonna change it to ribbit and swim. I'm also gonna make the same change here when printing the function. Finally, I'm going to create this another function which will check if an animal passed as argument is a duck by trying to call from this animal object the function quack and swim. So we have the duck class with the function quack and swim, printing this phrase quack and swim. The bird class also with the same function definition, and the frog class which changes the definition from quack and swim to ribbit and swim. And we have our check duck animal here to check if the object passed as argument will be able to call this function quack and swim. So let's create a main block here to test how our code behaves. So I'm going to create an instance of each class duck, bird, and frog. Now we are going to call check duck for each one to see what happens. So we have duck, we have bird, and we have frog. So let's see what happens by executing this code on the terminal. Oops, I forgot to save the file. Let's try it again. Okay, Now we have something. First, we have quack and swim, which comes from this call. Then another quack and swim, which comes from this call. And we have an exception, an attribute error coming from this call. What it means is that check duck was able to call quack and swim from duck, from bird, but not from frog, because frog doesn't have this definition of quack and swim like the other two have. So the first and second objects, duck and bird, could successfully respond to the quack and swim call while frog couldn't. In terms of code, we can easily check that duck and bird are not related at all. They don't share a parent class through inheritance, but they have the same interface for the function quack and swim. The interface is what matters, not the type of the object. So I could also change this print to anything. It would still work because what really matters it's the interface here. Let me just go back to what it was. So in the end, if the object behaves like a duck, for practical purposes, it is a duck, no matter what bird it is, as long as it has the right interface. But what do we do about the thrown exception? I mean, this is not nice to see an error like this on the output. Since we don't check the type of the object, or if it has a certain attributes like the quack and swim function we need, the Pythonic way to handle this situation is to use a try except block. So we would change our code to look like this. Let's create this try except block. We have an attribute error, so we are going to catch this attribute error as error, and I'm gonna print this error here. So now let's try to run the code again with this extra try except block here. Now we have a way nicer output, like frog has no attribute, quack and swim, which is what we expected. So in the end, we always assume the object has the method or attribute we need. If it doesn't, we catch the exception with the try block and treat it accordingly